Sir, what grade class am I in?
Hello.
Sir, which grade class am I in? I am from 9th, batch 3.
This is actually Icse 10th class.
Sir, then this was actually the link that was given to us on the like for 9th class, sir.
9th CBSE, right?
Yes, sir.
Not this one. I think something other. This is.
Sir, nothing is like updated on the group also, sir.
Just a minute then. What's
Yes,
your name? Shriya.
my sir, Shriya.
Hello, Shriya.
Yes, sir.
Sir shared you another ID. Check that once.
So where, sir?
Another one, not this ID. Just now I spoke with sir. Sir already shared.
Okay.
See that, and if you have any another ID, wants to test with that.
Yes, thank you, sir.
Okay. Shreya sir here joined.
Shreya? Okay.
New chapter, different book. In school, in your school, not following this. Okay, notebook. Okay, fine. You maintain another one. Chemical bonding now. Just tell me what you wrote in the last class. Farhan and Vaibhav, are you hearing me?
Yes, sir.
That
Noble gases.
Noble gas. Read last two lines.
Sir, helium has duplet configuration and noble gas has octet in their valence shell. These elements are more stable and do not participate in a chemical bond.
That's only.
Yes, sir.
I think I told you one more point also.
the driving force for atoms to
Yeah, that point only over now.
Yes.
After that, I didn't thought anything. Right?
Yes, sir.
Okay. Okay. Very calm. Okay, just listen now. Okay, silent. What you are checking? What did you find? What is that? There is a dog or hippopotamus or anything. What is that? Monkey. Huh? Don't know. And dog won't have that much stretchable body. That's what did you find? I'm asking you what you find. Monkey only, monkey. Then monkey mean it have long tail, no? Where is? It's okay. Stop it. Okay, listen now. Which and all the factors useful or supporting for formation of ionic compound? Just listen. Later I will give notes. Now, factors for ionic compound. I will write on board just. Factor favor for ionic bond. Listen, very simple points. You know, to form ionic bond require two species. There is one is cation, another one is anion. These two species are required to form ionic bond. Okay, here which one is favors? We'll see first. Ionization enthalpy. We have cation and anion. Cation is made by metal or non-metal? Metal. Anion is made by non-metals. So I'm taking right like this, E minus something Y or whatever. So to form cation from the element, that metal atom should have lower ionization enthalpy. Already we discussed what is lower ionization enthalpy. The amount of energy required to remove electron is called ionization enthalpy. So if suppose element have lower ionization enthalpy, those elements very easily forms cation, no? Correct? Suppose you have two elements, lithium and cesium. Cesium very easily forms its cation than lithium. So that means cesium is easily forms ionic bond. That's the meaning. Got it? Next, electron affinity and electronegativity. If you come into this part, anion part, so the elements which having higher electronegativity and higher electron affinity, okay, they are more ready to accept the electron. They easily forms anion. Okay, so metals which having lower ionization enthalpy, they easily forms cation. Non-metals which have higher electronegativity and higher electron gain enthalpy, they easily forms anion. Then this kind of species, two type of species, easily forms ionic bond. Clear? What are the favor for ionic bond? Okay. Vaibhav, Farhan, any doubt?
Yes.
What? Come here. Come. Oh. What he told? Okay. Right. First one. First point. Lower the value of ionization potential. Lower the value of ionization potential of a metallic atom greater the ease of formation of greater the ease of formation of the cation. Copy. The next point is about electron gain enthalpy. We say electron affinity. Higher the value of electron affinity, higher the value of electron affinity of a non-metallic atom, greater the ease, means easy, that means ease of formation of the cation. Higher the value of electron affinity of a non-metallic atom, greater the ease of formation of the anion. greater the ease of formation of the anion. Finish. Now tell me. Formation of the anion. What? Electron gain enthalpy. What is the anion? Negatively charged. What is the meaning of electron affinity? Electron. That's what. When any atom gain electron, that atom releases amount of some heat. If that is releasing more amount of heat, mean it having more capable to maintain negative charge. That meaning. So those are easily involving in ionic bond now. So to form ionic compound, what we require? Cation and anion. So because of this process, very easy to easily gives the anion. Then easily forms the ionic bond. That is cation. What about anion? Fluorine, chlorine, they forms, right? Okay, next point is larger the electronegativity difference. Next point. Larger the electronegativity difference between combining atoms. Between combining atoms. Wait. Electron transfer takes place easily. Electron transfer takes place easily. Now I will write two compounds. Electronegativity is also. You tell me which is more ionic compound according to this point. If you wrote this point, once carefully read and try to understand what is the meaning of the point. To form ionic compound require two atoms. The two atoms only we say combining atoms. Fluorine have more electronegativity. Okay, well, most only fluorine.
What is electronegativity difference?
Electronegativity mean
No, sir, difference.
I will write two
Electronegativity.
atoms. See their electronegativity also I will give. Suppose nitrogen combining with fluorine. Nitrogen electronegativity 3. Fluorine is 4. Sorry, 4. Next, cesium fluoride. I don't write bond. Actually, ionic bond means we should not show bond. Very mild bond is there. Okay. Anyhow, for your understanding, I'll give no problem. And CSF, cesium is 0.7. This is 4 only. So here, what is the difference?
1.
1.
1.
Here, what is the difference? Right? 3.3. Now tell me, which compound is more ionic, 1 or 2 according to this point?
2.
This
2.
is second compound is more ionic. That's it. Actually, in exam also they will give you 2 compound, which is more ionic means wherever you observe more electronegativity difference, that is ionic. Another one go becoming a, you can say covalent. We have 2 type of compound, ionic compound, covalent compound. This is more ionic means you can say this is more covalent, or you can say less ionic. That's it. That is the meaning of the point. Okay, next subheading. Formation of a covalent compound. Right, ionization potential, electronegativity, electron affinity. Ionization potential, electron affinity, and electronegativity. Should be high to participate in covalent bond formation. Next point is electronegativity. Difference should be electronegativity difference should be negligible. Electronegativity difference should be negligible between the 2 combining atoms. Between the 2 combining atoms. Done. Yes. See, earlier I explained to form ionic bond, requirement is cation. Cation should be metal, anion should be non-metal, right? But here to form covalent bond, both combining atoms are non-metals only. Non-metal mean in the periodic table right side you have some chlorine, fluorine, nitrogen, oxygen, phosphorus, these, sulfur. Bond between those non-metals only gives covalent compound. A bond between metal and non-metal gives ionic bond. Okay, so to form a covalent bond, these are the requirement conditions. See the first one, ionization potential. What is the definition of ionization potential? Very good. When remove an electron from the atom. Outermost. Right. That's good. Very good. That is only ionization potential. What is electron affinity? By the atom. Okay. Yes. Electron affinity mean amount of energy released when atom gain one electron. That's electron affinity. And electronegativity mean tendency of an atom to accept electron from its side. Already I told you this. It's like a tug of war. This side fat boy, this side thin boy. Who will win the game? Who will win the game in this tug of war? This fat boy, right? The same way, when two atoms combine through a chemical bond, one of the atom having more tendency to pull electron towards itself. Polar, okay. That atom only we say more electronegative element. But here, according to this point, the two atoms are maintaining almost high electronegativity only. So when element having high ionization potential, higher electron affinity and higher electronegativity, both the atoms, both combining atoms maintain this, those elements easily forms covalent bond. For suppose I'm taking chlorine. Chlorine is high ionization potential maintaining, high electronegativity, high electron gain enthalpy to maintain. Chlorine. Even nitrogen also maintain. Nitrogen also maintain almost higher values only. Now a bond between chlorine and nitrogen is what? Ionic or covalent? Covalent. When bond between potassium and chlorine, potassium and chlorine, think where is the potassium location in the periodic table? Potassium and chlorine. Potassium is metal. Chlorine is non-metal. So the bond is ionic bond. But this chlorine and nitrogen bond is covalent bond. So whenever bond between two non-metal mean it is mostly it's covalent only, no doubt. When a bond between metal and non-metal comes means you have to consider as a ionic. Clear? Okay. And charge neutrals. Second point is electronegativity difference should be negligible between the two combining atoms. So chlorine electronegativity here 3, nitrogen also 3. How much difference? 0. Sometimes it has some value also, but that's very small value only. Like a bond between fluorine and oxygen, fluorine electronegativity 4. This is 3.5 difference. 0.5. It's a limited value, very small value. So we can say it is a covalent bond only. When difference is like 2, more than 2 mean we are considering ionic bond. If you 1 or 1.5 also we say the ionic covalent bond only. Okay, that is about. That's what I am telling. If it is more than 2, difference is more than 2, considered as ionic. If below 2, electronegativity of chlorine, electronegativity of nitrogen. How much difference? Already I gave you a few element values. Yes, you didn't noted. electronegativity. Don't worry, no need now, because if you know that is metal element, metal is non-metal, enough. If you know both are non-metal, bond is covalent. One metal, one non-metal mean you say ionic. That's it. Okay. That also. Next, write one definition. Electrovalency, small subheading, electrovalency. The number of electrons donated or accepted the number of electrons donated, accepted by the valence shell of an atom of an element so as to achieve continue. Stable electronic configuration is called electrovalency. It's called electrovalency. Copy this. Which subject? School, no? Next week only, no? So have I conduct here also on test? Or you want preparation? Okay, this week only. Okay, mostly tomorrow I will bring for you one question paper. Mostly 90% I will try to bring for you. Okay, I will take 5 or 10 minutes class. Otherwise, I will post in group. You can get that. No problem. I will speak with Sarah. That's what I will bring 3 or 4 copies. Take and practice at home. Yeah, important questions. So you refer the answers first, write and learn answers. The important questions you learn. After that, write the same paper. Okay. So listen here. Noted all of your definition. You Bhargav, Farhan.
Yes, sir.
Yes, sir.
Silent. Come. What? Any doubt? Holidays you are. When do you have holidays? Started your holidays? Okay, yours? April 23rd, after exams? Okay, okay. So full of May you have holiday. But your school starts now in the May? Okay, okay, finish the definition. Okay, see the definition. The number of electrons donated or accepted by valency shell of an atom of an element. That's only we say electrovalency. I will explain you example. See, don't write, just listen. Later you may copy. Na and Cl. What is sodium electronic configuration? First, 281. This is 287. Is it stable? Is this stable? No. So
No,
that's
sir.
why sodium is losing this one electron. It become Na plus and 2,8 configuration. Cl is gaining that one electron, become Cl minus 288. Okay, okay, listen. What is electrovalency of sodium according to definition?
Sir, 1.
Very good. Your answer? Right. Read carefully definition. Right. Just once carefully read the statement. Read carefully statement, you both. First 2 lines carefully read. Then, yeah, one only, one, just one. See the definition, the number of electrons donated. Sodium donated electron. How many electron donated? 1. So its electrovalence is 1. Now chlorine, how many electron it gained? 1. So electrovalence of chlorine is that also 1. Clear?
1.
Is whatever there is gain or loss, that is only definition, right? So you can call 1. That is oxidation state, +1 -1. Yeah, why you are taking this much time? Okay, so now suppose another example. What is magnesium electronic configuration? 282. Oxygen?
26.
26. You know, this is not stable. Even this is also not stable. That's what magnesium giving 2 electron to oxygen. So magnesium given to oxygen is taking that 2. So it become Mg plus 2 and O2 minus. So it forms MgO. It formed MgO. So EB of magnesium, how much? EB of oxygen. That's not mandate. Sometimes it changes also. I will give now try this example. First magnesium oxygen configuration down Mg plus 2 and O2 minus, or you can write simply MgO also fine. Yeah, their values changes now. Magnesium is 2, but chlorine is gaining 1 electron. It was different. Right example. You. Hey, don't be overconfident. If you want, you can show. Electron transfer now, you can show like this. Not compulsory. Your name what? Arnav. Day before yesterday, afternoon, what did you eat? Day before yesterday, afternoon, what did you eat in lunch? See, you forgot. Then after 2 days, you will forget this also. That's what I told you, right? Write in notebook. Come here. You also. Okay, I can understand how it is. I'm not degrading you. I'm telling you, write the examples. What? Yeah, important thing. No, you will learn, but it should be in the notes. You are writing very slowly. Your name is Darshan, right? Important thing only. Are you writing? Done. Example also. Okay, so that's completed. Now oxidation and reduction is important. Very important, much useful for your high standard also. I will tell you in higher level only, not just this one. You learn now only. Huh? Oxidation. So I'm defining in different ways. The first one is addition of oxygen. Carefully listen, leave me copy. Addition of oxygen is oxidation. Removing of hydrogen, that's also called oxidation. So loss of electron, also called oxidation. These three different ways we are defining. So depending upon requirement, we are using any definition. Okay. In some, if you go organic compounds, there we are using hydrogen, oxygen, adding or removing. But in this chapter, we are discussing about electron losing or electron gaining. You will know now. Now you will know. So you are saying, you know, +1, -1, +1, -1. Those comes under oxidations. How compound is formed? How to explain? We need charges. The charges are here only. We are giving. Your shirt have some stain like red color dye. How to remove that? What we are using? Detergent. So how it works? Depend on this. Oxidation and reduction. Suppose sometime some stains are very sticky, they won't come. So that time using bleaching powder. Bleaching powder works, and not only that blue color, it completely removes your full color and finally it become white color. So that's doing by bleaching powder. So what is the role of bleaching powder? It is acting as a oxidizing agent. There are a lot of uses. Okay, right. Definition. First definition is addition of oxygen or remove of hydrogen or loss remove or loss of electrons. These all comes under oxidation. So under this only, examples of oxidation process. Right, I will give you examples. Yeah. Okay, see then examples of oxidation process. First example, I'm taking sodium only. Sodium, it became Na plus 1 electron. So here observe, sodium became Na plus means loss electron or gain electron. Loss electron. So Na became Na plus means loss electron. We call this is undergone oxidation. Sodium undergone oxidation. Next, zinc. It became Zn plus 2 and 2 electron loss. So here we say zinc undergone oxidation, but losing 2 electron. Here lost 2 electron. Next, iron. Fe became iron. Fe. It became Fe 2 plus 2 electron came out. So 2 electron. Like we have many examples. Zinc, magnesium, and aluminum. Magnesium became Mg2 plus 2 electrons. Aluminum became Al3 plus 3 electrons. Okay, next. That is depend. But suppose magnesium, what is atomic number? 12. Electronic configuration 282, right? By losing 2 electron only, it becomes stable now. That's what magnesium, when it loses 2 electron, it becomes stable. Mg2 plus. Like, oh, you can write anyway. Oh, that's okay. You can write anyway. +2 or 2 plus. Same only meaning. Same meaning. Copy that, all examples. Lead and iron, 2 valency. Already +2. You mean this? This. Also oxidation. Very simple. Is it lost electron or not? Check. Fe2 plus. Mean here lost 2. But when it became this, lost 3 electron. It mean overall lost no. So we say oxidation. Already 3, no, then why it become again 3 electrons? Show me, come with the notebook, come here.
Sir?
Yeah, tell me.
Sir, for formation of NaCl,
NaCl.
Sodium undergoes
Oxidation.
Oxidation, right?
Very good. Yes, loss of electron, no, oxidation. That is the oxidation.
And chlorine will undergo reduction, right? Because it gains.
Yeah, chlorine undergone reduction. Gained electron now. Correct only. Oh, tell me. Correct, ma. This also it is lost electron or not? Lost 3 electron lost. So oxidation. It lost 10 electron also. We say oxidation. 1 electron lost. Say oxidation. Loss of electron, we are saying oxidation. Finish. Next, reduction will write. See here, completely opposite. Addition of hydrogen is reduction. Or removal of oxygen is reduction. Gain, whatever they wrote there, exactly opposite. Here addition of oxygen is oxidation. Wait. Here addition of oxygen is oxidation. Under reduction, what we have to write? Addition of hydrogen you can write. And here removal of hydrogen. There removal of oxygen. Here remove loss of electron. There gain of electron. That is the reduction. Addition of hydrogen or removal of oxygen. Or gain of electron. Cl Cl minus, it becomes Cl minus, that is reduction. Okay, write examples. Examples of reduction process. S plus 2 electron. Sulfur gaining 2 electron. It became S2 minus. For Cl2 gaining 2 electron, it became 2Cl minus. Then Fe3 plus 1 electron, it became Fe2 plus. So that is also we call reduction. Gaining no electron. Cu2 plus 2 electron, it became Cu. Also reduction. Copy this all. Nitrogen, right? N plus 3 electron, N3 minus. Nitrogen and aluminum, it give covalent bond. Why it is? It comes in higher standard. Don't worry, Puna. Three plus. That's what you say now. Ionic bond because of only electrons, but you need to study some other properties also. It comes in higher standard. According to that, we say that is somewhat covalent. This is chlorine, Cl2. First thing, sulfur, what it is gaining 2 electron? Gain of electron is reduction process, right? Here chlorine, 2 chlorines are there, 2 electrons. So it became 2Cl means 1 chlorine gaining 1 electron. 2 chlorines gaining 2 electron. That's also reduction. Fe3 plus. By gaining 1 electron, it became Fe2 plus, right? So that is also a reduction. Cu2 plus, by gaining 2 electron, that became Cu. Here already it is lost 2 electron. 2 plus means lost. Again taking 2 electron means reduction. Nitrogen gaining 3 electron means reduction. Done now. Now, oxidation and reduction process suppose simultaneously occur, means at a time. That's what we call redox reaction. Write that down. Finished examples. Write definition. If oxidation and reduction redox reaction occur simultaneously, called redox reaction. Yes, yes. Yeah. Yeah, very good. Right, example. Example is Zn plus CuSO4. It became ZnSO4 and Cu. Write this example. I will show you now. Wait. ZnSO4 plus Cu. ZnSO4 plus Cu. Okay. See here how oxidation and reduction occur. Zinc. It became ZnSO4. It means to form this ZnSO4, zinc lost 2 electrons. Why I wrote zinc as ZnSO4? It will comes in next topics. I think actually you have to learn that in 9th standard only. Zinc sulfate formula charges also. Zn became here to become to this mean zinc lost 2 electron. What is this process name? Think carefully. Zn became Zn plus mean what is the process name?
Oxidation.
Oxidation. Very good. It is oxidation. Loss of electron. This is oxidation. Now here actually copper having +2 charge. It became normal copper. Means what happened? 2 plus became 0 mean gained electron. So this is reduction. Reduction. Okay, tell me now. This is redox reaction or not? Yes. Oxidation process, reduction process both occur simultaneously. We say it is a redox reaction. Right. Now metal displacement reactions all are coming under redox reaction. So you know battery, inverter batteries are normal cell batteries, small batteries, all are working on redox reaction only. Lithium and hydrogen, not hydrogen. Lithium batteries are using lithium, some other cadmium. Okay. Yeah. H2 that adding giving H2SO4. H2SO4 is adding sulfuric acid. Okay, next. Okay, now we'll go to examples for some ionic compound. Example of ionic compound and their formation we'll discuss. Don't know. I already gave you dot structures. How formation. That's now we'll discuss that. Ionic compound and covalent compound sharing, ionic compound losing, and I will show with diagrams now. Right, subheading formation of yeah. Yeah, that only we'll discuss. Ionic compounds. First one, sodium chloride. Bracket NaCl formation. Now I will give you on board that count. See, based on that, you can make any compound. We show with electronic configuration. It's easy. Both are same. But their sharing, I will show you ionic covalent compound. Here, transfer of electron, I will show you an arrow mark. See now. Okay, first NaCl now. I am writing, already wrote. So again, you write, no problem. First sodium here, right? And maintain some distance. Chlorine right here. Okay, sodium number electronic configuration. Okay, that's we will see under covalent compound. Here writes electronic configurations. 281. This is 287. Now I am showing arrow mark. Look, this one electron giving to chlorine now. So like this. So electron is going here. It become sodium losing electron now. So by sodium by losing electron, it gets the nearest noble gas configuration. Which one? Neon. You have to say that. Sodium lost one electron, 10 electrons only. 10 element atomic element is 10 electron contained element. Neon only. So sodium gets stability by losing one electron and gets nearest noble gas configuration of neon. That point, if you want, it will be better. If it is asking for 3 marks, you have to write that point. So I'm writing that point. Right. Sodium attains here. Sodium attains stable electronic configuration of the stable electronic configuration of the nearest noble gas neon. So sodium lost one electron and now it become Na plus, right? Na plus electronic configuration 28. Stability mark. Sodium attains stability. Sodium attains stability. Missing weight. Sodium attains stability. Oh, electronic configuration. Sodium. Okay. What you wrote there? That did you strike with that? This stable only. Stable electronic configuration only. Sorry. What we have to write about chlorine? Yeah, chlorine gaining one electron now, 288. So sodium attains stability, stable electronic configuration of argon by gaining one electron. Write that downside. Chlorine attains stability. Okay, attains stable electronic configuration of argon by gaining one electron. One electron. Now it become Cl minus electronic configuration 288. Write that. This kind of questions asking for 2 marks or 3 marks, no? So you need to give at least this much. In exam also you need to give this much. What is the element electronic configuration? Just 1 point. Very easy, no? Finish. That's also okay. Electron dot structure also okay. Three marks. So write something extra. What you know. Finish. Yes. So we got Na plus and Cl minus, right? So in the last line, write this. The last line, write Na plus Cl minus, it give NaCl. That's one way. Next, electron dot structure also I will show. So electronic dot structure is sodium have how many valence electrons? One only, right? Valence electron. Keep one dot. Chlorine? 7. So this is giving one electron. Okay, I will wait. Top only. So here. No problem. Yeah, you can guess. So anyway, so electron giving here sodium, no? Then it becomes sodium last electron mean Na plus. This gets chlorine, no? Because of 8 electrons, it keep 8 dots, gained 1 electron, it become minus. So then NaCl. That's it. Outside you can keep, inside also no problem. Plus, right now NaCl. So why bracket compulsory mean in one atom no problem, but sometime you need to take a group of ion, that time must require bracket. Done. Your name, I forget. What is your name? Right. Can you write your one? Write your calcium oxide formation. Calcium oxide formation. Two. Hey, full explanation. This much explanation you have to give, not just in one line. Don't complete. Next one, formation of calcium oxide. Over yours. Hi, you know how to do, then carry on. Formation of calcium oxide. Formula CaO. How to form this? So first we need to write the element and their electronic configuration. Elements, calcium, oxygen. Electronic configuration.
Two eight eight.
2882, right? Calcium. Oxygen 26.
26.
So here, these 2 electrons transferring here, it become 8. So right here 1 point. Calcium attain stable electronic configuration of nearest noble gas is argon by loss of 2 electrons. So it gets stability by loss of 2 electrons. The same way about right oxygen also, gain of 2 electrons.
Sir,
Yeah, tell me.
sir, I wrote this, sir. Can I leave? I have prayers.
Okay.
Bye, sir. Thank you.
So oxygen attain stable electronic configuration of nearest noble gas neon by gain of 2 electrons. By gain of 2 electrons. So calcium lost 2 electron, oxygen gain 2 electrons. So now right here Ca2 plus electronic configuration 288, oxygen is 2 minus 28. Okay, write directly equation plus gives rise. That's also issue. CaO. There is statement, you didn't write one statement also. Okay, then correct.
Sir,
Yeah, tell me.
is this all like for today's class? Is this all for today's class?
Yeah, it's over. Just one equation I will write, then
Okay.
electronic equation. That
Okay, sir.
okay, copy into this one. I will write here that that equation. Copy this. Dot structure. So with green color, I'm writing dot structure. Calcium, how many valence electrons it have? 2. Keep like this. Oxygen have 6. So this electron going here, this electrons are coming here. Then it become Ca 2 plus. And oxygen getting 8 electrons in the valence shell by gain of 2 electron. It become 2 minus. Then right, it gives rise. Product is CaO. That's all. If you write, then you can leave now. Bhargav?
Yes, sir. I'm right. Yes, sir. I wrote it.
Okay, then you can leave now.
Thank you, sir.
Okay, take your book. In mostly maximum 2 classes, I will complete this. I will start. Third week, this week, no, next week, mostly.